Well, I think Harry is ready. So welcome back to the last session before the last panel this afternoon. And again, it wasn't in the program. It has replaced Igor Kropnik. But we're really happy that Harry Stern is going to be talking about navigability indicators for the Northwest Passage and the Northern Sea Route. Harry is a researcher at the University of Washington Polar Science Center. He can tell us a little bit about himself before he starts.
Thanks, Pablo. Harry Stern, Polar Science Center. I've been glad to see all the presentations here that highlight the work going on at the Polar Science Center about ice thickness and other topics. So I'm going to talk about this is another presentation about sea ice indicators. We saw one yesterday from Walt Meyer and one earlier today from John Walsh. This is another way to look at the sea ice. A climate indicator is a quantity that's meant to be of use to stakeholders that can be easily computed, easy to understand. So I am in the process of devising this navigability indicator for the Northwest Passage and the Northern Sea Route. This is work in progress with other colleagues, so I'll show you the results I have so far. It's not finished yet. So first, let's look at the Northwest Passage. Of course, there are many routes through the Northwest Passage. This is just one particular route here that goes through Prince of Wales Strait and across Viscount Melville Sound. And what I've done is extracted, this is for one particular day. This is August 15th of 2009. The color coding up here is the sea ice concentration according to the passive microwave data from the AMSR-E satellite, with a 6-kilometer grid cell size. So all I do is extract the sea ice concentration along this route here, and that's plotted up here on the lower right. So the horizontal axis is the distance along the route, and the vertical axis is the sea ice concentration. And as you can see, for this particular day, there's a blockage up here. There's high sea ice concentration in Viscount Melville Sound. That's this big hump over here. So what we can do is we can calculate the fraction of the route that is ice-free. And when I say ice-free, I mean less than 15% concentration, because that seems to be a kind of a standard for defining what ice-covered and ice-free is. So for this particular day, we can calculate what fraction of the route is ice-free. And we can do that for every day for 10 years. Here's an example for the Northern Sea Route. We've got, starting up here in Bering Strait, going along the coast of Russia. There's, for this particular day, August 15th, 2009, the route is completely open except for this blockage here at Vilkitsky Strait, which you can see on the plot down here on the right. We have 0 sea ice concentration for most of the route, but then there's this blockage here. So again, we can calculate what percent of the route is ice-free on this particular day. Then what we do is summarize the results. So on the left is the summary of results for the Northwest Passage for that particular route that I showed, and on the right for the Northern Sea Route for the particular route that I showed. And each colored curve is one particular year. Along the horizontal axis is time, with the summer months only are shown: June, July, August, September, October. The vertical axis is the percent of the route that's open, according to that 15% sea ice concentration threshold. So as you can see, throughout June and July, more of the route becomes open. It kind of peaks in August and September, and then as the sea freezes again in October, the fraction of the route that's open goes down again in October. Now, the interesting thing to note here, which is not too surprising, is that in the early years, which are the blue curves, these particular routes never reached the 100% ice-free threshold up here. There was always some amount of sea ice blockage in the 2002-2003 timeframe. But by the end of this 10-year period, by 2011, there was quite a substantial period of time when the routes were 100% open, completely open, which you can see both on the Northern Sea Route side, on the Northwest Passage side, where these red curves, which are 2011, hit the 100% mark up here. So, as I said, this is a work in progress. I intend to update this with data from 2012 through 2017, but this illustrates the point of the Northwest Passage and the Northern Sea Route shipping routes opening up. Now, there's another, as I said, this passive microwave data has a 6-kilometer grid cell size, which is kind of crude when it comes to some of these narrow straits along the passageways. For example, Belet Strait is 25 kilometers long, but only 2 kilometers wide. That's a narrow strait that in the Northwest Passage that separates the Boothia Peninsula from Somerset Island, and it's used by many ships that transit the Northwest Passage. So we have to use some other data source to look at Belet Strait. So here I've got 2 examples of visible imagery. Yeah, Belet Strait is up here in the Canadian Arctic. These top 2 images are from the MODIS sensor. That's on NASA Terra satellite. And MODIS has a 250-meter pixel size. You can see this dark strip across the middle here is Belet Strait. This is for a particular day. This is July 7th, 2017, just a couple weeks ago. Interestingly, there was ice on both sides of the strait, but the strait itself is relatively ice-free at this particular time. But I've blown up a little piece of the strait over here, and you can kind of see the pixels and the blockiness of even at the 250-meter pixel size. Now these lower pictures are from visible imagery from a new company called Planet.com, and Planet provides imagery with a 3-meter pixel size, and you can really see the difference here. This is the same day, the same region, and you can see all these interesting sea ice features right in Belet Strait. Very, very detailed and really nice imagery of the entire Belet Strait. Now, this company, Planet.com, they've launched hundreds of satellites. They're tiny satellites like the size of a shoebox. And their goal, which they haven't quite reached yet, but their goal is to image the entire land surface of the Earth every day at 3 to 5 meter pixel size. So it's worth checking out. So the other half of this project, that was the sea ice half, and the other half is about marine mammals. And so we're interested to see where the routes of the Northwest Passage and the Northern Sea Route intersect with the ranges of Arctic marine mammals, bowhead whales, belugas, narwhals. So we've done a lot of work combing through the literature to find the ranges of various whales, Arctic marine mammals. In this picture, you can see the ranges of 2 bowhead whale populations, the western and the eastern populations that intersect with the Northwest Passage. So the idea is that there's potential conflict here between shipping and marine mammals, and it's something that we're going to try to quantify. Here's the equivalent picture for the beluga whale September range. You can see there's 2 populations here. There's the Chukchi population and the Beaufort population, and there are other populations along the Northern Sea Route as well. So the sea routes are the cross-hatched areas, and the September ranges of the beluga whales are the colored areas here. And finally, here's the picture for narwhals. Here's the size comparison, by the way, of these whales. So there are several narwhal populations within the Northwest Passage. up here along Baffin Island and up here by Somerset Island. So there's potential conflict or disturbance of marine mammals if there were to be an increase in shipping through these areas. So one of the reasons I came here was to try to gather some shipping data so that I can help to quantify what the vulnerability would be. The idea is to create a vulnerability index for each of these populations. And we define vulnerability, as other researchers have defined it, as the product of exposure times sensitivity. Exposure is just based on the overlap of the animal range with the shipping route. And we can calculate that from once we know the ranges of the animals, and once we define the width and the length of the route, we can calculate overlap. And then from the shipping data, we can calculate potential shipping traffic in the overlap region. And then the sensitivity has to do with what the response of the animals would be to a disturbance, such as acoustic disturbance. And for that, we're, again, combing through the literature to look for studies on marine mammals and shipping to find out how sensitive these different species are to disturbances. So then we'll be able to create this vulnerability index for each population. This picture on the right here shows ship tracks in September of 2016. I grabbed this off of a Norwegian database called Havbase, and you can see there's tracks all over the place. Pretty heavy up here in the Northern Sea Route, also through the Northwest Passage here, and in Baffin Bay, where there are plenty of marine mammals as well. So that's really most of what I have to say. This is a bonus slide. This is showing the number of complete transits of the Northwest Passage from 1977 to 2016. Now, in some previous talks, we've seen people present data on shipping, the number of ships going through Bering Strait or the number of ships along the north coast of Alaska. But it turns out that there have been very few complete transits of the Northwest Passage from one end to the other. In fact, there have only been 255 complete transits ever since the first one by Amundsen in 1903, 1906. And half of those transits have occurred since 2009. And so I've only plotted from 1977 to 2016 here, but you can see it was just a few ships per year. I've broken it down by what type of ship, but you can see the big increase starting in 2008 or 2009. And you can see from the color coding that the big increase is basically private yachts, adventurers, sailboats going through the Northwest Passage just to check it out, just because they can, because it's melting out now more consistently in the last decade than ever before. So whether that means more commercial shipping in the near future, I don't know, but that's so that's our sea ice indexes and the marine mammal connection. All right, thank you.
Thank you, Harry. Harry, thank you for sharing this new research. So you have a vulnerability index. So it's vulnerability to what? Is it to noise, to hits, to pollution, all of the above?
Yes, yeah, all of the above. We're looking at, because there are some studies that look at ship strikes of whales, other studies that look at acoustic disturbance. So we're going to take everything into consideration that we can find. Yeah.
Thanks. You do have an online question. If there are any other questions in the audience, please ask for the microphone. Why doesn't the narwhal's range extend further west to Alaska, for example? Because you know the psychology of the narwhals, and you could answer that.
Yeah, no. I read some journals of early explorers along the coast of Alaska from, it was Frederick William Beechey in the 1830s, where he described being served narwhal meat by the natives and how horrible he thought it was. So I know that there used to be narwhals there, maybe there still are, but Frank, to tell you the truth, I'm not a marine mammal expert, and maybe David Douglas knows, but the main body of the narwhal population is where I showed it on that map.
Any other questions? David, would you like to? David, would you like to expand? Okay. So you're not a narwhal psychologist either. Don't know why they avoid Alaska. Any other questions from the audience? Okay, there's one more online, Harry.
Okay.
Bonus question.
Yeah, bonus question, good.
Do you know if Planet.com has had any interactions with U.S. agencies here in Alaska? I guess the person writing this is in Alaska. Regarding their monitoring programs and how the 3-meter satellite products can help?
Yeah, I don't know. You can easily look them up on the web, planet.com. It's a commercial outfit. They sell their data, but they have what they call an ambassadors program, where they provide data to researchers for free. So I've obtained their data at no cost. And again, their mission is to map the entire land surface of the Earth. Now, sea ice is not land, obviously, but because the channels of the Northwest Passage are so narrow, they can't help but hit the coastal areas. So I'm sure they have data available along the coast of Alaska. How far offshore it goes, I don't know, but you could check with the company.
Well, I would like to propose an extra hard applause to Harry for having covered his time slot.
Oh, thank you.